Good day, everyone, and welcome to the Energy and Climate Resilience for Environmental Remediation call. My name's Sue. I'm your event manager. During the presentation, your lines will remain on listen only. If you need assistance at any time, please key *0 and an operator will be happy to help you. I'd like to advise all parties this conference is being recorded. And now I'd like to hand over to Scott Hartzell. Please go ahead, Scott.
Thank you, Sue. Hello, everyone. Welcome to our presentation for March in the Parsons Technical Webinar Series, Energy and Climate Resilience for Environmental Remediation. We are glad to have you with us today. We have a team of presenters today. Catherine Sheen and Jessica Bennett will be presenting. A few things that I wanted to mention. This course presentation has been approved for PDH hours. So if you are in need of continuing education units, please just respond to the email, get me a note, and we will get you a sign-in sheet and process a certificate for you. The other thing that I want to mention for those who are regular attendees of our presentations and our series here is that next month we will be using a different platform. We will be moving from WebEx to Microsoft Teams. You do not need to have Microsoft Teams loaded or have a license or any of that sort of thing. But in about 3 weeks when we send the announcement out for that presentation, you will see slightly different call-in information, and it'll explain how to get into the presentation at that point. So, next slide. Our standard housekeeping items, everyone's phones are on mute, and we do have an opportunity for you to submit questions during the presentation using the Q&A feature within WebEx. We will hold those until the end of the presentation, and then we will allow anyone to ask questions either through the ones that are submitted through Q&A or that want to unmute and ask a question at that time. And we would ask that you would give us your name just in case we need to follow up with a more detailed answer than what we can do on this call. Our agenda today involves introducing our speakers to you, and then we will turn it over to them for a core value moment as we start all of our meetings, and then our presentation, and we will save maybe 10 minutes or so at the end for a Q&A session to answer any questions that you might have. Our presenters today, we are blessed to have with us Catherine Sheen, who is a Technical Director of Sustainability and Resilience at Parsons. She brings to us 18 years of experience in both the engineering and architecture side dealing with sustainability, and she is an SME here in planning and implementation and also in documentation of sustainability and resilience measures on architectural and civil infrastructure projects. And she will be joined by Jessica Bennett, who is a senior environmental engineer with 13 years experience, and she specializes in identifying some innovative approaches for our projects that are cost-effective and increase sustainability and resilience. With that, I'm going to turn it over to Kat for our core value moment.
Great, thanks, Scott. At Parsons, we have 6 core values, as shown here on the slide: safety, quality, integrity, diversity, innovation, and sustainability. And given the topic of today's webinar, the core value moment will address sustainability. So the Parsons definition of sustainability that you see here reflects our commitment to the triple bottom line in our corporate activities, the services we deliver to clients, and in our employee culture of giving back to the communities in which we live and work. In our organization, our sustainability activities are broken down into 2 main avenues: corporate operations and project or program delivery. On the corporate side, we have 3 focus areas, beginning with human capital, which addresses topics related to our internal stakeholders, or our employees, and our overall corporate sustainability culture. Market presence represents the face of Parsons sustainability and resilience in the marketplace, and this includes things such as our memberships and representation in organizations like the Institute for Sustainable Infrastructure and U.S. Green Building Council. On the governance section, this addresses our internal leadership, policy and process development, the development of metrics and targets, and our interdepartmental collaboration, which is represented by this complex org chart of collaborating relationships that we have with other groups and departments that ranges from communications, supply chain, and corporate real estate, among others. Our sustainability team is also represented in the Environment and Social Governance, or ESG, Steering Committee, and plays a major role in developing and reporting on our public-facing corporate social responsibility disclosures. And on the project delivery side, while it looks smaller, we serve 5 business units grouped into 2 main revenue units, collaborating with business development to pursue, win, and deliver project services. This month, we launched our new Environment Social Governance, or ESG, site called CARE, which stands for Cultivating a Responsible Enterprise. And this public-facing website allows us to provide more regular information on our ESG activities, including our disclosures following the Global Reporting Initiative framework. So moving into the technical section, I wanted to provide a bit of an introduction to the concept of resilience because it's hard to look at resilience without considering its relationship to sustainability. So the way I like to distinguish between resilience and sustainability is to say that the focus of sustainability is mitigating the impacts of our designs on the environment, while conversely, resilience considers how the projects and systems we designed respond to influences of the natural, social, and economic environment over time. So in other words, when we think about sustainability, we think about mitigating our environmental impact through practices like energy conservation and reducing carbon emissions. And on the flip side of that coin, resilience requires the ability to adapt through system durability, response planning, and anticipating future changes to the climate, so that we can proactively design and or upgrade systems to anticipate the changes in future conditions. So the optimal solution is when sustainability and resilience overlap, such as in the case of preservation of open space, which both serves as a carbon sink and allows for mitigation of climate change, first serves as a carbon sink to mitigate climate change, as well as providing a means of adapting to sea level rise, increased precipitation, or flood risk in a low-lying area. Now, in this presentation, we're focusing on resilience to climate-related stressors, whereas resilience could also address human-induced hazards. But for the purposes of today, some examples of the type of hazard that are considered or that we recommend be considered in a resilience evaluation and remediation projects are mostly related to climate change. These can include things like sea level rise, extreme weather events like hurricanes, a trend of increased precipitation over time, which can also influence flood risk and storm surge, in particular if you're in a coastal area. And then in certain areas, drought becomes more of a problem over time due to extreme air temperatures, increased overall global temperature, and that can also lead to things like wildfires and permafrost melting. So the goals of our resilient remediation design are to recognize which hazards are present in your project location, understand what an acceptable level of interruption would be due to those hazards, and ensure that the design provides capacity to adapt to those anticipated conditions. So to give you a sense of the steps involved in resilience planning, I'm going to go through 4 major phases in this process. First, we have to do an investigation to understand the existing conditions, the performance requirements of the system in question, what potential interactions it might have with the broader internal system or other related infrastructure systems, and the potential stressors that could impact the overall performance requirements. The next step is to determine the vulnerability of your system or design, and that includes the evaluation of the probability of the occurrence of each of the identified hazards and mapping it with a severity or magnitude to determine where the most important risks and vulnerabilities lie. So where high severity and high probability overlap in the upper right-hand corner or red portions of the chart represent the prioritized vulnerabilities. And then the areas, you may also identify areas of strength, which are represented by the green portions of the chart where severity and probability of a particular hazard is low. So then we move to the mitigation stage because you can't start to strategize how to fix a problem that you haven't defined yet. So based on that risk evaluation, the hazard identification, and then the vulnerability assessment, priorities can be set, as well as starting the discussion of parameters for acceptable recovery. And solutions that mitigate the highest risk, or the red areas, first should be prioritized, and then specific criteria can be established to estimate the value of the activities in terms of reducing exposure to those risks. And then lastly, but certainly not least, in the monitoring phase, the key is to work with planners and other decision makers to create a framework that allows for ongoing assessment and mitigation. And this allows for planning of capital programs or system expansions. And it's important to establish exercises to test the effectiveness of the mitigation so that you can continuously improve, and also provide education to communicate the outcomes to interested internal and external stakeholders. So how do you get started in establishing, either doing your risk and vulnerability assessments or evaluating which resilience measures will be most effective? And so the next couple of slides, I'll discuss a few of the many resources that are out there that can help you get this process started. The EPA has a website dedicated to climate resilience for Superfund sites. It includes a wealth of information about adapting climate change and building up resilience to extreme weather at contaminated sites that are undergoing cleanup. And so you'll see the vulnerability assessment, resilience measures, and adaptive capacities. All of these are hyperlinked. And they include tools and data sources to identify potential hazards, description of possible measures that could be implemented to create physical or process-based barriers that improve resilience to those hazards, guidance for how to plan for adaptive capacity, and periodically assess the site vulnerabilities over time, in particular if they are anticipated to change, which is pretty common. And that adaptive capacity is mostly relevant for remediation solutions that are anticipated to be in service for a longer term. EPA says 30 years or more. Then there's some fact sheets to assist with prioritization and implementation based on specific remediation system types. As you can see, remediation, groundwater remediation systems, contaminated sediment sites, contaminated wastewater containment systems, for example. And then there are two other manuals, the Superfund Green Remediation Manual and the Climate Smart Brownfields Manual, both of which provide guidance that's aimed at reducing the overall environmental footprint throughout the life of remediation activities. So it's not just a single portion of the project, but it starts with site investigations, cleanup alternatives and remedy design analysis, the implementation or construction of the selected alternative, and then following all the way through to operations and monitoring. And the strategies that are, the impact reduction strategies that are included in these manuals focus on energy and water use reduction, increasing the use of renewables, reducing air pollutants and greenhouse gas emissions, which is often associated with a reduction in energy, conserving materials, reducing waste, and then the more conventional environmental focus of protecting water and land-based ecosystem services. are 3 other organizations I wanted to point out which also have guidance documents that can be useful in your education and technical implementation processes, beginning with the Interstate Technology and Regulatory Council, or TRC, which has a green and sustainable remediation guidance document, which is often abbreviated as GSR for green and sustainable remediation. It has guidance on integrating sustainable practices into existing site investigation and remediation programs. Similarly, the Naval Facilities Engineering Command, or NAVFAC, has its own GSR manual, and it also provides guidance throughout the life cycle of site characterization, remedy selection, remedial design and construction, and long-term operations and monitoring. And the Sustainable Remediation Forum is a great resource for both educational materials and metrics comparisons, depending on the type of remediation project you're working on. They also have this site-wise tool, which was developed jointly by the U.S. Navy, the Army Corps of Engineers, and Battelle, and that calculates an aggregate environmental footprint of different remediation alternatives. So if you're trying to compare different options and come up with a metric for deciding the environmental performance of each of them, then the site-wise tool might be one you'd want to look into. In addition to regulatory guidance or the documents from EPA and these other agencies, I wanted to point out that there are third-party sustainability rating systems that also have resilience components that are either already integrated or under development in pilot programs. So if you're working on a LEED project or an Envision project that's pursuing certification from the USGBC or the Institute for Sustainable Infrastructure, respectively, you may find that an additional benefit to implementing resilience into your project design is that it can enhance your score for these sustainability rating systems. So Envision has an entire section dedicated to climate and resilience, which if you dig into it, you'll see it also follows the paradigm of assessing hazards, determining vulnerability, setting goals for risk and resilience, and then actually establishing the strategies and implementing them. On the LEED side, there's a series of pilot credits related to resilience, and they are taking it beyond the conventional view, or perhaps a slightly narrower view of looking at resilience to climate hazards, and also looking at safety and in particular pandemic planning, which you can imagine has become a focus in the past year. And in the case of pandemic planning, the resilient solution selection in the case of remediation would likely lean towards a lower energy consuming solution that has more self-regulating or automated capacity to reduce the necessity for human beings to interact to make the system work. So what's the value of this overall? At a high level, I would say that the 2 primary benefits resulting from integration of climate resilient strategies in your remediation projects are near-term cost savings and reduction to life cycle financial and reputational risk. So there's a lot of ongoing research that's attempting to better express those benefits in terms of dollars, but here are a few examples of quantifiable short and long-term potential payback. So from the perspective of short-term impacts of severe weather, according to the U.S. Department of Education, extreme weather events are the leading cause of power outages in the United States. And to put a number to it, between 2003 and 2012, an estimated 679 weather-related power outages cost between $18 and $33 billion, that's with a B, in damage to the U.S. economy. So these losses aren't just associated with service interruptions and physical damage to the electrical grid, although those are part of it, but it's also associated with lost output and wages, spoiled inventory, delayed production, and other inconveniences. Another powerful example from recent news that some of you may have experienced personally was the extreme weather in Texas last month, which caused extended disruptions to energy delivery and extraordinary damage to the physical and social systems, not to mention putting human lives in danger. So this is an example of the sizable cost and the domino effects that non-resilient infrastructure can have on healthcare, transportation, education, and communication systems, all of which are essential to our social connectivity, culture, and overall quality of life. So looking long-term at the benefits of resilience planning, a study performed on a series of FEMA mitigation grants showed that the upfront cost of climate resilience strategies saves $4 in post-event damages for every $1 spent on pre-event mitigation. And that's just for direct property damage from earthquake, flooding, and hurricane wind, so not counting all of those domino effect impacts to other social and economic systems. So what this indicates is that a better understanding of patterns of exposure and the geographic, socioeconomic, and systematic vulnerabilities can really be used to make more effective long-term plans, including funding allocation and addressing potential areas of exposure to reputational risk, which, if you don't address them, could damage both public perception in addition to all of the system disruptions and physical damage that I've already mentioned. And lastly, the long-term secondary losses like decline in property values, associated decrease in tax revenue, loss of attractiveness to business and tourism, and not to mention psychological trauma. You know, we really can more effectively mitigate all of these potential impacts if we recognize they exist and address the primary causes in the near term. So with that, I would like to turn the presentation over to Jess to discuss 2 case studies.
Thanks, Kat. So hopefully that set a really good backdrop for why it's so important to consider resilience, especially in remediation projects. It's often not a primary consideration. It might be incorporated unintentionally or just coincidentally with other evaluations for what the best remedial approach is, but it's becoming increasingly important to formally consider resilience as well as sustainability for remediation projects. As Kat mentioned, the most important thing is to start out by identifying your potential hazards, which really vary by where your site's located and what your site-specific kind of conditions are, and then going through the standard alternatives analysis or feasibility study process, but including consideration of resiliency. In situ or passive remedies often have the best climate and energy resilience because they don't require much input once they've been implemented. But in the case where more energy-intensive, pump and treat or air sparging systems are really the best approach from a technology standpoint to achieve the remedial objectives, it's really important to consider, how sensitive is that system to fluctuations in energy or impacts from climate events? What's your allowable downtime based on, regulatory requirements? There are sites out there that have to operate 24/7, 365, no matter what happens, and you have to kind of build redundancy and resiliency into those projects to make sure that they can stand up to those potential hazards. As always, even standard feasibility studies, it's best to destroy or stabilize your contaminant mass. That includes if, in the case of capping, where a standard capping approach may not be resilient enough to potential climate hazards, but if you stabilize it and then cap it, that would be improved. Or conversely, you might need to relocate the impacted material elsewhere on site in an area that would be less impacted by changes in, water level rise or other factors. So to kind of give everyone a sense of what potential climate hazards you might be facing for a particular site, this is a map of all non-federal Superfund sites in the U.S. And which climate hazards they potentially face. So the colors for each of the symbols on the map correspond to the colors in the table on the bottom right. And so you can see that over 60% of sites are potentially impacted by one or more climate change hazards. So that's kind of a good parallel to what you might encounter wherever your sites are across the country. So to give a little more detail on this, this is not to say the only hazards that are present in each of these areas, but it kind of focuses on specific hazards. Out in the west and southwest of the U.S., wildfires are a particularly significant hazard to sites. As we've seen in recent years, it's becoming more and more frequent to have wildfires, and they're more severe and larger. And along with this also comes, more significant and severe droughts. So that's a really important consideration for sites out in the west. Along the Gulf Coast, sea level rise is one of the more significant climate hazards, but certainly not the only one. And notably, the sites that are the orange circles along the coast are sites where they're already potentially affected by sea level rise with no further increase in water levels. Along the East Coast, storm surge hazards are a significant concern. As we saw with Hurricane Sandy, that was a fairly unprecedented impact from a hurricane. And we've seen tropical storms that can be just as damaging. So storm surge is a particular concern, among others. And out in the Midwest, flooding is actually one of the bigger concerns because all the various river systems are prone to some pretty severe flooding as precipitation events have become more frequent and more intense. So to kind of exemplify potential ways to incorporate resilience and sustainability into remediation projects, I'm going to present two case studies. The first one is an industrial site in the Mid-Atlantic. So the requirements for this project was to extract groundwater and convey it using existing 2-inch monitoring wells, which in itself presented some challenges. So there wasn't a significant amount of volume we had to pump and convey, but there was a significant topographic change across the site. So that meant there's a wide range of groundwater elevations and well depths that we had to incorporate in the design. Further complicating things was the fact that the site, although it's an active industrial facility, the wells were located almost entirely in very densely wooded vegetated areas with limited access, at best dirt or gravel roads, and they didn't exactly go along all the wells. You often have to drive, all the way around the site, the long way to get to the next location. You can't just drive from point to point. And they were spread out along over 7,000 feet of distance, so they weren't even close to each other. The system's only intended to operate for 2 to 5 years as an interim measure until the long-term remedy is implemented. But it also had a very short time frame for design and implementation of only a matter of months. Because of that and all the other factors to this project, we started out by doing a conceptual design evaluation of how to provide power to pumps to extract water from these wells. And convey it along such a long distance over such changing topography. We identified that there was line power already available at the site, but from 3 separate facilities and entities that operated kind of independently across the site. So we would have had to run several thousand feet of power from each of those 3 entities to get power to all the different well locations. We also would have had to put in additional equipment to go from, higher voltage, 3-phase alternating current power to what we would need at the actual wellheads for pumps. So we looked holistically at, line power versus solar power. And from a cost standpoint, both capital, O&M, and salvage value. And capital cost-wise, it came out very, very similarly. O&M also was very similar. And salvage value was pretty substantial for solar, especially compared to conventional line power. We found that solar would be much more implementable, especially in a very short time frame, to not have to coordinate with 3 different entities or have to work in such challenging terrain and conditions. It was based on that, it was, slightly safer for the solar installation. O&M wasn't substantially more for solar, so that really wasn't a detractor. And it was also going to be a more resilient and sustainable approach because we weren't, reducing greenhouse gas emissions using renewable energy. And in the event of severe weather or flooding, which that area is, occasionally occurs, we wouldn't be reliant on a third party to provide power to the system. So a little background about solar. I'm sure everyone's seen it's becoming much more prevalent these days, both on residential, on rooftops and stuff, as well as the utility scale. There's a lot more solar farms that you see either airports or along the highway. And that's because the cost has really dramatically come down the past 10 years. It's about a tenth of what it was 10 years ago. At the same time, the efficiency has dramatically gone up, as well as the reliability and lifespan. Most panels these days have a 25-year warranty, and other components have also similarly, become more reliable and with longer lifespans. So solar is a great thing to consider for any remediation project where either there isn't existing infrastructure for power or it's not cost effective to, run lines and connect to it. As well as, standalone projects where, you may not need a lot of power, but you need, certain things that are easier for solar. In terms of power demand, there's no limiting factor for power demand. You can either potentially supply all of your power with solar if it's not too significant for the footprint you have available, or you can just offset your electric demand. If you've got a treatment system, you can put solar on the roof or somewhere nearby the treatment system and offset your power demand, which also increases your resilience in the case of, outages from the grid. It can streamline the process, especially if you're doing an off-grid system or it doesn't require connection to the utility. But that in itself shouldn't be a detractor either for considering solar if you do want to do a grid-tied system. And ultimately, it can also really help with sustainability of the project and the client's goals with that. It's becoming increasingly common that clients want to, make sure that sustainability is incorporated into the project holistically. And just for context, the graph on the lower right shows the cost of new utility-scale wind and solar on the left side compared to existing conventional generation from coal, nuclear, and gas. So you can see that this is why solar and wind are becoming so much more prevalent for new construction of plants because they're very cost competitive with the existing conventional generation. So if you're looking at solar for a project, a really good place to start is the National Renewable Energy Lab has a calculator called PV Watts. You can put in your site location. It'll bring up an aerial, and you can kind of mark out what kind of footprint you might want to put solar on. It'll give you a lot of really good screening level data to let you know how much power you might be able to generate with the area you're looking at. Beyond that, you really want to look at what area is available and suitable that doesn't have too much shading or some other impact that would make solar challenging. How much power do you need, whether it's for a single extraction well pump or a treatment system or something else? And, how large of a system do you need in terms of how many panels do you need backup storage in terms of batteries and how much? And then you're going to put it on an existing structure or a building or put it on a ground mount system. Security is also a really important consideration. These systems look really nice and shiny, especially when they're mounted on the ground and not on a roof, and can be very attractive to people who may not have the best intentions. So if it's on a site that's not secured, it's an important consideration for security as well. And finally, permitting, as in all projects, is a key consideration from the beginning. If you have to do any kind of tree removal or just disruptive work that might have ecological impacts or limitations, as well as, electrical permits, you may have to get an electrical permit inspection, even with an off-grid system, depending on the county or city requirements. So these are two photos of the two different size systems that were installed for this project. The different sizing was based on the designed capacity requirements of each of the different locations based on where they were in the system, their depths, and things like that. They're fundamentally the same components. It's just a matter of how many solar panels and how many batteries are installed for each. The silver boxes in both photos is where all the batteries and other components are installed to basically take the power from the panels and then store them into the batteries and then transfer them to the well pump. We also have remote monitoring for all the systems, both for solar, how much it's producing. We also have the ability to put have data inputs from sensors from the pumps or some of the other controls so that we can remotely monitor it. We don't have, we didn't build in a control system because it really wasn't necessary for a system of such short duration, and given what else is going on the site, there wasn't a need to have like actual remote control of these systems. And then finally, for security, a really cost-effective solution we found was to put DeWalt mobile locks on each of the battery enclosures on the inside that will send you an alert if there's any kind of movement, vibration, or things like that. There's a bunch of sensors in it, and for a very cost-effective price of a couple $100 or less, it will actually alert you and even tell you if it's moving or if the device has been taken off, and you can track it. So kind of in summary, by going with solar on this project, we really accelerated how quickly we could implement this. It really wouldn't have been possible to meet the regulatory deadline and avoid all the really high penalties if we gone with line power. There were too many coordination constraints that would have made it impossible. We also simplified the process and implementation time by not having to install power across 7,000 feet of difficult terrain. The installation of solar took about 2, maybe 3 weeks in total for all 7 systems, with a crew of maybe 6 to 8 people at most at any given time, sometimes less. And by using a subcontractor, we can streamline the whole design process and kind of have them focus on solar and do the installation while, Parsons staff focus more on the rest of the design for the extraction and conveyance system. Again, with solar, it's a more resilient project because it's not reliant on any third party for electricity. The sun's going to come up. It's just a matter of how often, for how long, but that's why we incorporate a battery system that would provide at least 40 hours of operation with absolutely zero charging. And based on actual operation, it's even longer than that. And as I mentioned before, it's a more sustainable project because we're using renewable energy that has less greenhouse gas emissions than conventional electricity generation. And these systems can be, repurposed after the project is over because they still have, 5 to 20 years of warranty left on the different components. Solar is a great thing to consider for any site, no matter what you have, whether it's just a single panel and a battery for a telemetry station or something more, larger scale like a landfill. They have ballast mount systems that don't penetrate the ground surface that are great for landfills, but really looking at any kind of underutilized space where solar might work and somehow benefit your project and make it more resilient and more sustainable. So the other case study I'm going to talk about it's another industrial site, but this one's in Northern California. And it was also a groundwater-related project, but the requirement was addressing exposure to receptors from impacts in groundwater, both for potential drinking water supply as well as discharge of surface water and potential vapor intrusion for any new construction in the future of the site. There were 3 main treatment areas that were evaluated: the source area control, which are the orange areas on the figure on the right, the dissolved phase plume, which is kind of generally the large blue outline, and then the down gradient surface water protection from discharge of groundwater to surface water. So as with most alternative analyses or feasibility studies, most of the technology screening criteria were very similar, with the exception of sustainability, which was a required criteria of the client. So we went through the screening process, and the table on the right summarizes the technologies that were retained from the initial screening to be evaluated in more detail. So you can see it really covers kind of a very broad range of technologies, from energy-intensive air sparging and pump and treat to capping, containment barriers, and then in-situ remedies from phytoremediation to ISCO. And all the technologies were retained for both at the upper and the lower aquifer, with the exception of air sparging and phyto, because they weren't going to be effective for the deeper aquifer based on depth. So for the sustainability portion of the remedial alternative evaluation, there were several criteria that were qualitative to reduce use of non-renewable energy, natural resources, minimize greenhouse gas emissions, as much as possible, also utilizing natural processes that would ultimately lead to beneficial reuse of the property, and as always, try to destroy or remove the contaminants to the greatest extent possible. Those criteria were then turned into some quantitative criteria to evaluate each of the remedial scenarios and technologies, which were non-renewable energy use, greenhouse gas emissions, highway miles driven, and worker exposure hours during implementation of the remedy. So the results of the evaluation were that the source area remedies were the best approach, because they targeted kind of get the most bang for your buck in terms of remediation than the larger down gradient plume scenarios. The climate change potential and energy use aspects were really dominated by the alternatives that included chemical reagents of one kind or another, based on the transport and manufacture of them. So the graph in the lower left shows the different ranges of energy use for different components. In particular, the two highest columns in that graph are for in situ chemical reduction reagents, which are much higher than for in situ bio or ISCO. So based on the holistic sustainability evaluation, not just energy consumption, but all of the other factors considered, source area control was the selected remedy using either in situ bio or in situ chemical reduction, with the addition of phyto in the upper shallower aquifer, and there's also M&A and institutional controls for both aquifers, which are pretty standard these days to transition to M&A after certain objectives have been met. So overall, the in situ bio had better sustainability than in situ chemical reduction, and that's largely due to the energy consumption for transporting and manufacturing the reagents for ISCO. And the present worth cost was fairly similar as kind of a trade-off for the two different aquifers, and kind of ultimately wasn't a deciding factor. In terms of greenhouse gas emissions, the graph in the lower right, you can see that the selected remedies on the right portion with the green arrows are the second lowest greenhouse gas emitting scenario, with only second to conducting only M&A and source area control. So in situ bio was actually the remedy that was implemented. It was ultimately selected over in situ chemical reduction based on effectiveness and sustainability, among other factors. And it was implemented using a combination of horizontal and vertical injection wells, shown on the figure on the right, and using EVO and some other amendments. Phytoremediation was also implemented for the upper aquifer, using a combination of eucalyptus trees in the upland areas and willows in the wetland portions of the plume area. And then M&A and in-situ controls were implemented, including, vapor intrusion mitigation for any new structures that might be built over this part of the site. So overall, by evaluating sustainability as part of the remedial alternatives to this project, it led to, increased sustainability by reducing the use of non-renewable energy, reducing greenhouse gas emissions, and utilizing natural processes in both phyto and in situ bio. It also was a more resilient approach because it relied on in situ remedies versus energy-intensive, pump and treat or air sparging. And there was special attention paid to, for phytoremediation of which trees were best for each area. Eucalyptus trees were selected in part because they're drought tolerant, and willows were selected for the wetland areas because they're capable of tolerating the occasional flooding and saltwater that occurs during extreme high tides in those areas. And again, in situ bio, as an in situ technology, it's essentially not affected by any potential future climate fluctuations that might occur. So in summary, hopefully you'll take away from this presentation, the difference between sustainability and resilience, which I always kind of summarizes the impact of the project on the environment versus the impact of the environment on the project. While they're very different concepts, they're very, very interrelated and should both be considered for remediation projects. The key thing is to start with identifying what are your potential hazards and determining how to mitigate the risk and the liability of those, and then implementing those measures and continually evaluating and determining if you have to make adjustments based on kind of the real world conditions that you're seeing during the project. I really hope that everyone takes away that it's important to consider energy and climate change resilience and sustainability from the outset of the project, or at least start wherever you are in a certain phase of a project. Get stakeholder buy-in by demonstrating the benefits, that it's not just a buzzword, but that it can really mitigate their long-term liability and risk, which can also really reduce potential costs if they didn't incorporate resilient and sustainable components. There's also secondary, benefits as well that Kat mentioned in terms of, community perception and then impacts on in terms of social or cultural aspects. And one last thing is that, closed sites, whether it's a closed landfill or a currently operating treatment system, likely didn't have a ton of consideration for sustainability or resilience when they were designed. So it can be important to kind of look at those sites and determine if there's anything that has changed that should be looked at further or maybe optimized to increase the resilience or sustainability for those projects. And with that concludes our presentation.
All right. Well, thanks to both Kat and Jess for the presentation. That was excellent. We will open things up for Q&A. We've got about 10 minutes here. So Sue will give you some details on how to submit a question here.
Thank you. So if you'd like to raise a question via the telephone, please key star then 1 on your handset, record your name and press the pound key. Please make sure your line's not muted. If your question's been answered or you wish to withdraw it, key star 2. You will be advised when to ask your question. Alternatively, you can submit your question via the WebEx. Please type it in the Q&A section on your screen and then click send to all panelists. Thank you.
Jess, I don't want to put you on the spot, but I'm going to do it anyway. A lot of folks out there are probably interested in some kind of idea about cost on something like this. Is there anything you can share as far as, giving people that kind of information?
Yeah, certainly. So for the first case study, just the power component of the project alone it was in the ballpark of $300,000 to $330,000 for providing power. And like I said, it was really comparable between solar and line power. So it wasn't any substantial additional cost. Plus, it had the benefit of a 26% federal tax credit that they could claim. So that comes out to about $80,000 or $85,000. And then there's also the salvage value for the solar components, especially because of the batteries that are lithium ferrophosphate. They're much more energy dense than your conventional 12-volt, marine battery, and they have a much longer lifetime at 10 years. So at the end of this project, after 2 to 5 years, the salvage value, it really will vary based on the market at the time, but it's probably in the ballpark of $100,000 or $150,000. So ultimately, big picture, more cost effective for solar.
And I'm assuming if we have a project that might be a candidate, that you'd be able to help us figure out, those kind of financial questions as to whether or not this is something that would make financial sense as well.
Yeah, and it really depends on the project, and I don't want sticker shock to happen. You don't have to spend $300,000 to implement solar. It's really project specific for what your needs are and how to best benefit from solar. It could be using a solar powered generator or just a single panel in a battery to do a remote telemetry system. It doesn't have to be a six-figure number necessarily. It just depends on the project.
All right. Any questions from others out there?
Currently, just one comment rather than question on the WebEx. Trent Rogers says, great information, thanks for sharing. And just quickly to remind you, if you wish to ask a question, it's star then one on your telephone, record your name and press the pound key, or submit your question via the Q&A section on your screen and click send to all panelists. Thank you.
Thanks, Trent, for the kind words there. Yeah, very good information here. Everybody another minute here, just in case you have something that you're really wanting to ask. Opportunity now.
And we've just had another question come through on the WebEx. Tim Ulti asks, how have regulators reacted to bioremediation with plants and trees?
I guess I will field that question. It really depends. I know there's some cases out there that I've heard of over my career where phytoremediation wasn't necessarily accepted by regulators, or maybe it wasn't particularly successful. But it really comes down to the project and the site conditions, the contaminants, and what is actually compatible, like in terms of uptake by trees, and also just the kind of the regulatory stance for any particular state on how they view the use of phytoremediation. So it's always worth considering. It's just a matter of, is it a good fit for a particular project?
Thank you. And Michaela asks, do any Parsons projects incorporate carbon offsetting programs for sustainability purposes?
Kat, do you want to take that one?
Sure. I guess, so carbon offsetting could mean a variety of things. If you mean purchasing carbon credits to offset known emissions that will result from either the design, construction, or operations of those projects, we currently have, to my knowledge, I have not been involved in any projects that are doing that. However, we are more and more being asked to evaluate the greenhouse gas emissions of project alternatives, whether it's for a regulatory requirement. Usually outside of the United States. And as part of those greenhouse gas emissions evaluations, we're asked to determine whether there is an opportunity for carbon sinks within the project site. So using natural systems to offset potential emissions that would result from the project. So using plants, primarily trees, planting of trees as carbon sinks.
Thank you. There are no further questions waiting.
All right. So, Kat, can you advance one more slide? I wanted to remind everyone our series picks up again next month on April 14th. Akshay Parenke is a relatively new employee at Parsons, and we've got him scheduled to talk about PFAS and the destruction of PFAS under ambient conditions. As I mentioned at the beginning of the presentation today, that will be on MS Teams, so you will see that. We will have an announcement out in about 3 weeks, so you will see that, and hopefully everybody can join us again for that presentation on April 14th. With that, thanks again to Kat and Jess for a wonderful presentation today, and we will close our webinar here. Thanks, everybody.
Thank you so much.
Thank you.
Thank you, everyone, for joining. That concludes your call. Please disconnect your lines and have a very good day.